In this video, we're going to talk about prime numbers. So first, let's define what a prime number is. A prime number is a natural number that has exactly two distinct natural number factors. So the key to this definition is that it needs exactly two distinct natural number factors. It can't have fewer than two, it can't have more than two, it has to have exactly two. So let's give an example of a prime number. An example of a prime number would be 3. 3 is prime because its only factors are 1 and 3. And of course we're just talking about the natural numbers here. So we've got two factors, 1 and 3, exactly two distinct factors. They're different numbers, 1 and 3, but there are two of them, so 3 is prime. Now when we talk about prime numbers, we also often wish to talk about another category of numbers called composite numbers. And the way we define composite numbers is like this. A composite number is a natural number that has more than two distinct natural number factors. So this is very similar to the definition of a prime number, except this time for composite numbers, instead of having exactly two distinct natural number factors, we need more than two distinct natural number factors. So let's give an example of a composite number. The number 4, for example, is composite. And the reason it's composite is because it has the following factors. Has factors 1, 2, and 4. 4 is divisible by all of these numbers. And now these form three distinct natural numbers factors. So that's more than 2, so that places 4 in the composite category. Alright, so now that we know the definition of prime and composite, let's go ahead and apply that to group a few numbers into the correct category. So remember, prime, that means exactly two factors. Whereas composite means more than two factors. So why don't we go through each of these numbers now and tell whether it's prime or composite. To do that, we just need to find all the factors of the number. So 5, for example, 5 has factors. What are the factors of 5? Well, we know there's 1, and we know there is 5 for sure. 5 is divisible by both of these pretty clearly. What about 2 or 3 or 4? Is 5 divisible by any of these? Well, 5 is not divisible by 2, 5 is not divisible by 3, 5 is not divisible by 4, so it's just factors 1 and 5. And these are exactly two factors, so that means 5 is prime. Okay, so how about 6? 6 has factors, well, clearly there's 1 and there's also 6, but what about all the numbers in between? We should check those too. So what about 2 or 3 or 4 or 5? So is 6 divisible by any of these? Well, 6 is divisible by 2. 6 divided by 2 is 3. So 2 is good. So 2 is also a factor. What about 3? 6 divided by 3 is 2, a whole number. So 3 is good. 3 is also a factor. Is 4 a factor? No. Is 5 a factor? No. 6 isn't divisible by 5, but here we've got factors 1, 2, 3, 6. That's 4 factors. So that means since this is more than 2 factors, 6 is composite. Okay, so how about 15? Now we're getting into some bigger double-digit numbers, but it's still the same idea. We want to see what are the factors of 15. We know there's definitely 1 and 15, but what about all the numbers in between? Like what about 2 or 3 or 4 or so on? So why don't we check through these numbers to start with. Is 2 a factor of 15? Well, 15 is not even, it's not divisible by 2, so no, 2 is not. What about 3? Oh, 15 divided by 3 is 5, that's a whole number, so 3 is definitely a factor of 15. And actually at this point we could keep on checking at all the factors, but at this point we can tell that 15 has more than 2 factors. We've got 3 factors right here, 1, 3, and 15. So based on that we can conclude that 15 is composite. Okay, so last one, how about 13? Again, we're checking for the factors, so 13 has factors, well, we know it has factors 1 and 13, but what about the numbers in between? Let's just go ahead and list them out. So there's 2, there's 3, 4, and so on. Well, we'll take more if we need it, but so is 2 a factor of 13? No, 13 is not even, so 2 doesn't go evenly into it. What about 3? Is 3 a factor of 13? Well, 13 isn't divisible by 3, so no. By that same token, 13 isn't divisible by 4 either, so no. So we haven't found any factors yet, but we need to keep going to 5, 6, 7, keep going there. Is 13 divisible by 5? No. How about by 6? No. By 7? Nope. How about 8 or 9 or 10 or 11 or 12? Let's check. So 13 divisible by 8? Nope. Not 9 either. Not 10, not 11, not 12. So we've got all the possibilities in between and we're just left with 1 and 13. So that's only 2 factors, which means that 13 is prime. Alright, so now we're getting pretty good at telling whether a number is prime or composite, so here are some trickier questions. First of all, is the number 1 a prime number or a composite number? Well, again, let's just think of the factors of 1. The factors of 1 are, let's see, well clearly 1 is a factor of 1, and itself is also a factor, but itself is just 1. So 1 is really the only factor. The only factor of 1 is itself 1. So 1 has a single factor. Okay, so we can tell it's definitely not composite because composite numbers need more than 2 factors. Okay, so not composite. So is it prime then? Well, remember prime numbers need exactly 2 factors, but 1 just has a single factor, so it's not prime either. So that means it's neither. It's neither prime nor composite. Okay, next question. Is every even number a composite number? Well, let's see. Let's think about this. So again, we want to find the factors. Factors of an even number are, okay, let's list them out. So clearly a factor is 1, and then there's also going to be the even number itself, and then also 2, because every even number is divisible by 2, right? So then that's 3 factors, and it looks like every even number is a composite number. So this is a tempting line of reasoning, but it's incorrect. To see why it's incorrect, why don't we work a couple examples? So first of all, factors of 4. What are the factors of 4? Well, according to this, it's 1, 4, and 2. So there's 3 factors right there, and that makes it a composite number. So yeah, I'd agree that 4 is a composite number. So great, 4 is composite. But how about if we try this argument on the number 2? Factors of 2. What are factors of 2? Well, there's 1 itself, 2, and 2. But we can't repeat factors because we need distinct factors, so we should erase one of those 2's. So we really just have 1 and 2 as factors of 2. And since there's just 2 factors, 2 is not composite. 2 is prime. So here we have an example. 2 is prime. 2 is an even number, but it's not composite. So no, not every even number is a composite number. But based on this line of reasoning, there is one thing that we can conclude. We can conclude that every even number greater than 2 is composite. So if we exclude 2, then that works. If we exclude 2, then every even number greater than 2 is composite. But if we're considering all the even numbers, including 2, then no. Those are not all composite because 2 is not composite. Great, so now we know how to tell whether a number is prime. And in the future, we'll learn about why primes are important. In particular, we'll see that any natural number greater than 1 can be decomposed into the product of primes.